Welcome back to the channel. So again, today the question we are solving is integration of 1 plus x to the power n and its whole power 1 upon n upon x to the power n plus 2 dx. So to integrate this value, what I am going to do is taking x to the power n outside. So x to the power n 1 upon n dot 1 upon x to the power n plus 1 to the power 1 upon n dx upon x to the power n dot x to the power 2. So I have taken x to the power n outside, so it will become x in bracket 1 upon x to the power n plus 1 to the power 1 upon n, and in denominator I have separated x n plus 2 as x to the power n dot x to the power 2. Now this value will become x dot 1 upon x to the power n plus 1 and its power 1 upon n dx upon x to the power n dot x to the power 2. Now I will be cancelling this x with this power 2. So x 1 upon x to the power n plus 1 1 upon n dx upon x to the power n plus 1, or okay, let it be x to the power n plus 1. Now what I need to take as a substituting value is 1 upon x to the power n plus 1 equals to t. Now the reason for taking this as a substitution, because if I try to differentiate this, let's proceed with the differentiation so we can easily get the reason why taking this as for substitution is differentiation of 1 will be 0. So let's not write it down, and differentiation of x to the power minus n will be minus n and minus 1. So dot dx equals to dt. Now minus x upon x to the power n plus 1 dx equals to dt. So now I assume you can easily conclude why I have taken this value as for substitution, because here dx, I have here dx, and in denominator x dot n to the power x to the power n plus 1, and here I have the same x to the power n plus 1. Now I can easily substitute these two values with dt. So that was the reason why I have taken 1 upon x to the power n plus 1 for my substituting value. So now putting all the values here, okay, one slightly mistake after cancelling it, I shouldn't write x value here. So this will become t to the power 1 upon n, and in place of dx upon x to the power n plus 1 will become my dt, and I will be sending this minus n value to this side, so it will become minus 1 upon n. Now we have to integrate this value here. So minus 1 upon n, integration of t to the power 1 plus n will be t to the power 1 plus n plus 1 upon 1 plus n plus 1 plus c. So now just simplifying this value, we can get our answer easily, minus 1 upon n. This will become n plus 1 upon n dot, and t will become t to the power 1 plus n upon n. Now this and this n will get cancelled. So minus 1 upon n plus 1. Substituting value of t will be 1 upon x to the power x plus 1 plus n upon n. So plus c. So this value is the answer of my question, but what I was given in my question was integration of this term was equals to a dot 1 plus 1 upon x to the power 4 to the power b. So if I say this, minus 1 upon n plus 1, 1 upon x to the power n plus 1, 1 plus n upon n equals to a 1 plus 1 upon x to the power 4 to the power b. So now I have to compare these two values to get the value of a and b. So in bracket I have 1 upon x to the power n, and here I have 1 upon x to the power 4. So if I compare these two terms, n will become my value 4, b will be 1 plus n upon n, and a will be minus 1 upon n plus 1. So putting value of n in these two terms, a will be equals to minus 1 upon 4 plus 1, and b will be 1 plus 4 upon 4. So a will be equals to minus 1 upon 5, and b will be equals to 4 plus 1, 5 upon 4. So this is the value of a and b, which I have got after comparing it what we got after integration. And the question was asking what is the sum of a plus b. So now you just have to add these two terms and we can get our answer. So taking LCM will be 20 minus 4 plus 5 5 25. This will be minus 21 upon 20. So this is the final answer of the question that was asking originally. I have solved integration. I have solved integration of this part in terms of n, and then comparing my integration with what was given in the question. On comparing, I got value of n, then putting value of n in these two terms for a and b, then I got the value of a and b, then adding these two value will give me the answer of this question that was asking in the option. It matches with 21 upon 20. Thank you for asking this question.